Hello friends, how are you all today? Have you ever wondered what are random variables and how they can be used in engineering? It's coming up right now. I'm Prashant from Dharini Academy of Technical Education, Bengaluru. We'll be discussing about random variables now.
Fine. We will start with the continuous probability distributions. Okay. So the first one is the exponential distribution. Okay. Did have we have not written the equations corresponding to the PDF annual, right? So okay, let's first start with that. Then I'll write the uh, equations required, right? So continuous probability distributions, right? So we know that the probability distribution of a random variable is going to help us in finding out what will be the probability for a given value of x, and we will also be able to calculate that what should be the value of the probability at a given particular point of x, and what value of the probability will be there for all the values before that x, correct? So CDF, one is CDF, one is PDF. Now we will write the equations corresponding to uh, those two quantities. Okay. Now in these distributions, right, the very basic point is that they are continuous along the x axis. For every value of x you have the probability. Okay, for each and every value of x you get one probability value, right? Now the probability function or the PDF. So PDF is equal to the P of x, what we used to write earlier, right? So that is f of x is always greater than or equal to 0. And if we write the f of x from minus infinity to plus infinity, minus infinity to plus infinity, the f of x dx is equal to 1. It's something like you are adding up all the probabilities. Like, so previous case when we had only 4 probabilities, p of 1, p of 2, p of 3, p of 4, if you add them we used to get 1, correct? So same thing here, we replace that summation by integration. So continuous probability is defined in this way. Now let's go further. If I want to use this f of x to calculate the probability that the x is between a given range, right? That is, let me denote it in this fashion. So probability that the a is less than or equal to x, less than or equal to b, probability that this particular x is between any two range, right? So we can find it as, it's just an integration, but between minus a to not minus a, sorry, it's between a and b. Okay, so this is plus a to plus b. So irrespective of what a b it is, okay, if you integrate that f of x between the given range with respect to the x variable dx, we get the continuous probability density integrated between them. All right, next we have this is corresponding to the PDF. Now similar to the PDF you have a cumulative, correct? So that is CDF. So how to represent CDF? CDF is capital F of x. Okay, capital F of x is nothing but the same in terms of the probability function. If you want to define, we can define it probability that the random variable x is less than or equal to a given value x. Okay, so that's how you define this x can be 3, 4, 3.5, 8, anything. What is the probability that a random variable takes a value less than or equal to that specified x is called as CDF. You see that our function actually is starting from minus infinity, correct? So if you want to calculate this particular probability, then you need to integrate from minus infinity till x. Okay, f of x dx, that is CDF. Now if I differentiate both sides, so I'm considering this is a LHS and this is the RHS, right? If at all we try to differentiate both sides, then what happens, right? I can differentiate, so this implies we are trying to find a relationship. So d f of x by dx, can you tell me what happens on the right hand side? So there is an integration. When you differentiate, it will cancel out the integration sign, correct? So that means it is simply f of x, right? So if you want to calculate, so we have a two relationship with us. If you know this, you want to calculate capital F of x, means you use this equation. Okay, and let me say that I know the capital F of x, I know the what you call, I know the CDF. Capital F of x is known to you, but you want to calculate the small f, means simply differentiate that. Okay, all right. So these relationships are very handy when we solve several types of problems. Okay, then this same thing, I'll try to write another notation because sometimes we need it. This can also be written like P probability that minus infinity less than or equal to x less than or equal less than or equal to capital X. Okay, so we have this representation. Okay, less than or equal to small x. So it's like if I want to relate this with this kind of expression, then I can use it. All right, so these are very important equations. So let's use some other relationships as well. So this is in general. Okay, if let me say r is any real number, okay, if r is any real number, then the following equations are always true. Okay, we have proved this in the statistics parts or the probability part. Okay, right. So the first one is probability that the x taking a value greater than or equal to r is equal to greater than r, in the sense r onwards any value till infinity, because x is continuous, correct? So that means you integrate from r to infinity, right? F of x dx. Okay, this is one equation. In the sense, I can actually do the reverse. If you want to calculate p of x less than r, right? So this means I just have to subtract 1 minus p of x greater than or equal to r, correct? So this means I can write it as 1, this is r to infinity, okay, f of x dx. So definitely you can do the reverse, it's minus infinity to r, right, f of x dx. Okay, right. In addition to these equations, we definitely need the mean and variance of any given f of x, right? So how to find that? Let's write the general equation. Okay, so mean mu is given by, it is integral minus infinity to plus infinity. This is x into f of x dx. So if you recall, the equivalent of this equation on the uh, discrete side, this was summation x into px, correct? So x was any value, p of x was, or px was the value of the probability at that given x. We used to sum it. Okay, now summation is being replaced by integration. Right. Okay. Now similar to this, we have the variance coming up. So denoted as sigma square is equal to, it is minus infinity to plus infinity, right? If you remember, we are supposed to subtract the mean from x, right? X minus mu was there. Now we'll write the same thing, x minus mu. Take a square of this, multiply by p of x. Now p of x is f of x for us in continuous case, dx. Okay, so we use these two equations to calculate mean and variance. So by default, I can definitely go for the standard deviation. Okay, SD. This is nothing but the root of mu sigma square. My mistake. Root of sigma square is equal to sigma. All right. So as required, we can use any of them. So this is the basics required from the concepts of probability, so that we can apply into a distribution of random variable. Okay, now let's go ahead and start the continuous distributions. So the first one is the exponential. All right, so the exponential distribution of any random variable x is denoted by f of x equal to, this has two parts. One is, this is alpha into e to the minus alpha times x for the x values greater than 0. Okay, and the function takes a value 0 else. So what is the meaning of this equation? When x is less than 0, function does not exist, means the function is going to be present only on the right hand side of the y-axis, right? That's the first thing, right? And it's a exponentially decaying function, right? E to the minus alpha x, right? So that suggests that it's a decreasing function as we increase the values of x. Right, now let's write its mean and variance. That's required for the calculation purpose. So the mean mu comes to be 1 by alpha. Okay, we had done the calculation part in the mathematics earlier sections, right? And the sigma square uh, is, if you want to calculate the sigma square, that comes to be 1 over alpha square. Okay, which means the sigma is root of that, it's once again 1 by alpha. Okay, then let's finish the theory part quickly. All right, I'll go with the other distribution as well. Now itself will finish. Okay, the second very important distribution in the continuous among the continuous distributions is normal distribution. Okay, the normal probability distribution under the normal distribution is f of x equals to 1 over root of 2 pi sigma square into e to the power minus x minus mu the whole square divided by 2 sigma square. Okay, this is the equation. X takes all the values from minus infinity to plus infinity. So here it's not defined, it's defined even for the negative side. Okay, so I will write the conditions: minus infinity less than or equal to x, less than or equal to plus infinity, and mean can also take the values from minus infinity less than or equal to the mu less than or equal to infinity, and the value of sigma is always greater than 0. Okay, under these conditions, if we substitute the values accordingly to the above equation, it will be called as the normal distribution. Okay, fine. So this is a valid PDF. When you take the integral from minus infinity to plus infinity, we get the same. We get it equal to 1, because integration minus infinity to plus infinity, f of x dx is always 1, right? So that we can prove here for this given expression, right? So where the mu itself is the mean here. Okay, mu is the mean, and let's say the variance, we can calculate the variance which is already given there. The sigma square itself represents the variance, right? So here we don't calculate the mean and variance separately from the given distribution, because distribution itself has the value of mean present over there, and the variance is also we can actually extract from the given expression. Okay, so that's the speciality of this normal distribution. There is another slightly varied version of normal distribution which is called as the Gaussian distribution. Okay, very similar expression, right? But anyway, in mathematics we need normal itself, but the Gaussian comes in most of the time communication. Okay, right. Yes, Gaussian is one of the very famous ways of distribution, widely used in communication, different aspects of communication technology. Right. Okay, now in order to find the distribution here, we need to have some changes in terms of the representation. So that is what is called as the standard normal distribution. In normal there is a small variation. Okay, this is important because we have an integration that is taking place from minus infinity to plus infinity, and the function also exists from minus infinity to plus infinity. That's very important here. All other distributions what we consider may be exponential or any other format, right? You see that it will be it's going to be presented only in some range. Okay, maybe a to b, okay, or minus a to plus b, something like that. But this is a distribution which is present always from minus infinity to plus infinity. So every problem you solve here, you are going to integrate from minus infinity to plus infinity always. So that term infinity makes it very complicated to integrate, okay, when you substitute. So to make things easier, always the values of this integration has been pre-calculated and presented for us in the form of a table. Okay, so any problem that you solve on the normal distribution needs to be converted into standard normal distribution so that you can simply refer a table to get the answer. Okay, so for that reason, we have to look at the concept of standard normal distribution just to understand that how to convert the given normal distribution into the standard normal distribution. Okay, now we know something. We will start from what we already know. If you want to calculate the probability that a less than or equal to x less than or equal to b, right? This is equal to, from basics we know that it is integration a to b the distribution function f of x dx, correct? Right. This means now I am supposed to integrate in the same fashion 1 over root of 2 pi sigma square, which is a constant. I'm going to take it out of integration. So this is say a to b. What is the distribution? It is 1 over root of 2 pi sigma square. I have taken that out of the integration. It is e to the power minus x minus mu the whole square divided by 2 sigma square into dx. Now let's make a substitution that I try to convert I try to eliminate this x minus mean, x minus mu, and I substitute that in the form of a new variable so that my function comes to the center. I'll illustrate what I mean. Okay, let me consider a x and maybe xy axis. Let me just plot it. So, okay, all right, this is my first axis. This shows the normal distribution. Okay, so the normal distribution is going to look something like this. All right, this is the normal. Right. In this case, in this kind of graph, the variables what we see is this is f of x, this is x, and we should be able to observe the mean at the center. Okay, so this is the mean value mean. Okay, now you see here I have a function x minus mu, right? If you put x equal to mu here, this value of x should be substituted as mu so that the numerator becomes equal to 0, correct? In other words, if you look at the signals aspect, you are actually supposed to move this to left. That's what is my meaning. I have to move this signal to the left so that this mean comes to the center. Ah, absolutely perfect. It has to be coming at the origin, correct? Now we'll do that. So in order to do that, what we do, this is the normal. I will convert this into the standard normal. I make the following substitutions. So whenever my intention is to go from the left to the right, okay, I make the following substitution so that the conversion becomes very easy for me. All right. So I will make a substitution saying that the z is equal to this term x minus mu whole divided by sigma. That is actually present over here. If you see here, x minus mu is there, it's a square. Sigma is also there, it's a square exists. So I can actually replace the whole thing so that it becomes a z square form. Right. So if you do that change, right, I will skip the mathematics part, the calculation I'll skip. I directly get the same probability represented in the following format. So that is, I'll call this as f of z. Okay. So if you make this substitution, I'm going to get the f of z in the following format. It is 1 over root of 2 pi. Anyway, the sigma square is going to get cancelled when we do the mathematics and we write it, we simplify, it gets cancelled. Okay, into e to the power minus z square by 2. Okay, so this is my expression for f of z. So what happens now? I'll draw that. Okay, so this is how it's going to look like. So now this is capital F of Z versus Z, and this gets changed into the following shape. Again, this is going to be its limits will not change. Still, it is going to exist from minus infinity to plus infinity, but we change the variable such that the mean is 0 now. Okay, 0 mean at the center, and it will retain the variance part. Sigma square is still retained. Okay, right. Now what is the advantage? Right? Why do you want to do so? If you remember, please answer that question. Why did you shift this from this? Anyway, I have not changed my limits, right? Limits still, initially I told that limits are from minus infinity to infinity, the integration becomes difficult. It is true, right? But after I convert the f of x into f of z, right, I still have the minus infinity to plus infinity, right there. But still, this actually has solved some of my problems. What is that? So when we want to integrate a specific range to get a probability, because this curve is about probability, right? It's a PDF, and if I want to have a value from minus a to plus a, I want to get a value, right? I can simply integrate only on one side, just integrate 0 to a, that gives you this much area, correct? But if you want to minus a to a, this is minus a to a, you simply take this area into 2, because symmetric, perfect, right? So that's the one very basic advantage of using the standard normal distribution over the normal distribution. Whereas if you want to go for the same calculation by using the normal distribution, maybe the minus a is here and the plus a is here. You see, it's completely different, right? You have to have completely different integrations to calculate the total area. Okay, so that is why uh, we converted this into the standard normal distribution at the first place. Then the second thing is that since this is very standard, right, you can directly convert this and save it in the form of a table. Okay, so do you have a soft copy or hard copy of the standard normal distribution table? Please find out, because we need it to solve the problems. Let us solve some of the basic problems before we go to the standard normal problems. Okay, say, yes, yes, yes. Now we start with the basics of those problems, then we come to the exact problems based on the exponential and normal. All right. So this is something like a general question on a PDF. Any PDF given, how do we find a specific answers to that? All right. So let's say if f of x is equal to, this is x by 6 plus c for 0 less than or equal to x less than or equal to 3, and it is 0 else, is a PDF. Find p of 1 less than or equal to x less than or equal to 2, comma, p of okay, 0.5 is less than or equal to x, probability that x is less than 2.5, less than or equal to 2.5. Yes, this is a question. It's actually not related to exponential or the normal distribution. It's a general PDF question. Okay, now we don't have to apply either of those standard equations. We have to use the basics of PDF to solve this. Right, right, right. So it says that integration, correct, correct. Now I have, see, there is a constant c here. Until and unless I know what it is, what value it's going to take, I cannot solve the problem. Okay, because when I integrate between 1 to 2, that c still is there, right? So we need to find the value of c. for which I use the property of any of the PDF. It says that if you integrate this from minus infinity to plus infinity, f of x dx, this is 1, which I know now. But in this particular problem, the PDF has been specified its value exists only between 0 to 3 and it is 0 otherwise, right? So that makes my equation to be represented between only 0 and 3. So integration 0 to 3, this f of x dx, that is x by 6 plus c dx equal to 1. Okay, when you integrate this, it becomes x by 12, correct? Uh, plus cx validating from 0 to 3, correct? So this is 3 square, 9 by 12 plus 3c, and on the right hand side this is equal to 1, right? Okay, so the c comes to be equal to 1 over 12, right? Okay, now we know the value of c, so we can actually rewrite the complete f of x, right? So let's write that first. Therefore f of x is equal to this is x by 6 for 0 less than or equal to x less than or equal to 3. Only this is the valid case, otherwise it takes a value 0. Right. Now the first part of the question says that find out what is the value of probability that x is between 1 and 2. Correct. So probability that x takes a value between 1 and 2 is 1 less than or equal to x less than or equal to 2. This is nothing but integration 1 to plus 1 to 2 f of x dx. Correct. So this means I am supposed to integrate between 1 to 2 the same function. This is x by 6 plus 1 by 12 dx. Okay, this is equal to 1 by 3, right? All right. Now, the next question, it says that probability x is greater than 0.5, right? Probability that 0.5 is less than or equal to x. What do you do? What integration we can do here? We have to find all the values more than 0.5. So minimum value is 0.5. H infinity, but I know that this function is only till 3. After that it's not there, so you just have to integrate till 3. Okay, zero point 0.5 till 3 f of x dx. Okay, so this is 0 0.5 to 3 x by 6 plus 1 by 12 dx. Are you okay? Okay, so this is 15 by 16, right? Alright. Similarly, we have another part in this question. X value is less than 2.5. So that means we are supposed to calculate P of uh, 2. Okay, X is less than 2.5. So I'll write the 2.5 later. Right. So X value is less than or equal to 2.5. So the upper limit is 2.5. What is the bottom limit? Correct. Correct, correct. So this is x by 6 plus 1 by 12 dx. 35 by 48. Perfect. Okay, that's how we solve this kind of problems. Okay, now let's solve one more of this type. So let's say if f of x is equal to k times x squared for 0 less than or equal to x less than or equal to 3 is PDF, then find the following. So first one is P of 1.5 less than or equal to x less than or equal to 2.5, probability that the value of x is less than or equal to 2, probability that x takes the value greater than 1, find the mean of this particular PDF and the variance. Oh, sorry. Okay, so this is a question. So first we need to find the value of k to get the complete representation of this PDF. So how do we find the value of x? The k, you need to integrate. Correct. F of x dx equal to 1, and we do that from 0 to 3. K x square dx equals to 1. Correct. So this is going to generate a value of yes equals to 1. So k as 1 3 will cancel. I think 9 is okay. Find out the value. Okay, the value of k comes to be 1 by 9. So now we will calculate the rest of the question, which is first we are supposed to find out the probability that it is between 1.5 and 2.5. To be 40 9 by 108. Next, we want to find the probability that the x value is less than or equal to 2. Correct? So this is integration 0 to 2, 1 by 9 x squared dx. Okay, that is 8 by 27. Now the probability we are supposed to find next is x greater than 1. So this means it is integration 1, yeah, maximum value is 1 going till 3. It's 1 by 9 x squared dx. Okay, so this comes to be 26 over 20. Okay, so for any given general PDF, we can apply these techniques to find out the required probabilities. All right.
That's all for the day. Feel free to contact if you have any doubts related to any topics in engineering. We can also help you in solving your assignments, projects, and many more. Thanks for watching. Good day.